In this video, we will be covering casting variables. More specifically, what it means to cast in Java, the things you must remember when you want to cast a variable, what it means to downcast, what it means to upcast, the benefits of casting, and the downsides to casting. We will also include examples of code, explain how to cast, and show you what the code is accomplishing. So what does it mean to cast a variable? Casting in Java means to take a variable of a specific type and turn it into another object type. However, there are limitations, as you cannot cast any variable to any type. So what are some things you need to remember when casting? You must remember that everything in Java is an object, and any object you create extends from object. This is actually called inheritance, and it is crucial to have a good understanding of it before getting into casting variables. One type of variable casting is downcasting. This is more common than upcasting, and probably what you are doing when casting. Downcasting is when you take an object and cast it into a more specific type of object. This is done to get a specific functionality to the object, basically making it more flexible. Now look at this model. Downcasting coincides with a downward pointing arrow. As you can see, person is the most general term, and as you go down the chart, the types of persons gets more specific, going from a person to an employee, then finally a manager or clerk, who is the most specific type of person on the chart. So here's an example of downcasting. The type object is a very broad type of variable, so we want to downcast it to be a string type. This can be done because the value stored in a sentence object is a regular string. So, much like in the chart, we go from object to string, making it more specific and giving the code more functionality. Now what is upcasting? Upcasting is the opposite of downcasting. Upcasting is when we take a specific type and cast it to a more generic type. Because of this, upcasting is almost always legal. In the example code, we go from string to object, going from specific to generic. And if you look at our example on the right, upcasting follows the upward pointing arrow, starting with cat or dog, which are specific types of mammals, and ending with animal, which is generic. What benefits come from casting? Casting allows us to be more flexible and do more with a generic object. Look at the example code. All of the objects stored in the map are of type object and are very generic, which is why we want to downcast it. We know name and emails are strings and birthday is a date, so we can downcast these safely. This allows us to have more flexibility with our code. For example, we now have a birthday date object, so we can access methods such as getTime rather than just default object methods. This extends what the code can do, which is the main benefit to casting variables. By creating the map with object as a value rather than something more specific, we are given many options as we can downcast to more specific types. If it were to be created with a more specific value, we would be far more limited. So what are some downsides or things we have to watch out for when casting variables? It is important to be careful when downcasting. If you were to cast a data object to an integer object, you would get what's called a class cast exception. This is actually called a runtime exception, as it is only detachable when the code is running. To prevent this error, be sure to know what type object you are casting. To sum things up, casting variables is used to take a specific variable type and change it into another object type. Casting variables is used in order to increase the flexibility of the code. Hopefully you learned a little more about casting variables in this YouTube video. Thanks for listening.